If you've ever been to the Orange River, there is a huge valley going down towards the Orange River. So we freewheeled for 40 kilometers. And how he fixed the car is a much longer story. Okay, he's a recipient of the Distinguished Teacher Award from UCT in 2000. He's a fellow and life member of the Geological Society of South Africa. And I didn't know this, he'd been awarded the Society's Jubilee Medal 3 times for particularly prestigious scientific papers. Internationally, he's a fellow of the Society of Economic Geologists, which is not a national one, a more international one, obviously, since 1998. So he's published, lectured, consulted widely on topics related to economic geology, mineralogy, and geochemistry, with particular emphasis on mineralization in the Namaqualand, Bushmanland, Namibia, and the Bushveld Igneous Complex near Rustenburg. He's also held directorships in mineral exploration companies on the JSE, and he retired from UCT in 2013, but he's a professor emeritus. I'll give you David.
Yes, I'll do this, and I'll take this. Well, thanks very much, John, and thank you for coming. It must be quite a marathon. It's now week 3, and it's almost Friday, so thank you for being very patient and waiting. John has sort of started us in the Cape, and so those of you who have actually, well, perhaps I'd better start with a question. Hands up those people who have never been to the Richtersveld. Okay. So let me turn this around. How many of those people have been to the Richtersveld more than once? Okay, so I'm preaching to the converted, obviously. And maybe I'm just going to connect the dots or fill in the gaps. But probably having got your attention, I can tell you why I have been there for about 25 times. Because I love the place. I do what I love, and I love what I do. And I love my wife, who's also in the audience. You may see her for scale. She's the scale in my outcrop of life. And she's suffered many, 40-plus years. So this title is called The Desiccated Edge of Africa. It is indeed the desiccated edge of Africa, as you can probably see from this coffee table picture. And where is it? Well, obviously a lot of you know where it is, but you probably can't get further away without actually needing a passport. You can see that it's actually hidden away in the sort of far northwestern corner of South Africa. It's not the furthest away from Cape Town. Those people who were at Nick's first talk, when he was talking about the Shashe Limpopo triple junction up in Mapungubwe, know that is the furthest away from Cape Town. But certainly those people who have driven families up to N7 and your kids are saying, are we there yet? And you've just gone past the oil refinery at Milnerton, and you know it's going to be a long trip. But it is worth it. And as I said, I'm preaching to the converted. So the Richtersveld, of course, is up there, big bend of the Orange River. There's plenty of big bends on the river, but this one's the last one. And we're obviously going to spend some time looking at this. As you know, it is a national park, a sand park, probably one of the most inaccessible. Just to get there, and then of course getting around needs high clearance vehicles. No one would drive there in a sort of ordinary low profile sedan. You're not allowed to, I suppose. The rangers will shun you. But of course it's a trans-frontier park. We know that the Fish River in neighbouring Namibia, it's not more of the same, interesting. I could give another talk just on the Fish River Canyon, which is a very different type of desert landscape. And we know that the cultural and what's the other heritage? Probably the biological world heritage. So you basically got the northeastern Richtersveld as a sand park, the southeastern Richtersveld is a World Heritage Site, and then of course you've got the western Richtersveld, which you can touch on in the talk, but we know that across the Orange River in Namibia, that is the southernmost of this fabulous Nama-Naukluft Desert Park that goes all the way through to Etoshapan and Angola. So it's obviously in safety, sooner or later, probably this whole area is going to be a massive nature reserve, a series of heritage parks. Well, I'd prefer to leave it on, but when the photographs start to get a bit dark, I'll turn the lights off. Is that all right? Okay, I want to make eye contact and see your body language. You can see my body language. It's part of the overall experience. Okay, probably this slide shows you a little bit of the same, but I suppose the main thing is that a lot of the interesting part of the Richtersveld is in the east, and you can see where all the mountains are. Whereas the western side, possibly why it's still sort of non-allocated, it's quite a heterogeneous ownership and custodianship, but it's actually a very vast, flat coastal plain, free of dunes. On the other hand, on the other side of the Richtersveld is pretty much the same as the western side. It's a fairly flat, featureless plain, unless you get to the Orange River. Anybody who's taken the bus, it's not like the Greyhound on the N7, you know you cross the Orange River about 3 o'clock in the morning, so you don't see anything. So those people put their hands up saying they've been to the Richtersveld on the bus. You've got to go there during daylight. So you can subdivide the Richtersveld into a series of sort of notional compartments. The eastern Richtersveld is probably the one that's been proclaimed and managed, whereas the west is obviously still pending. Now, the title, Desiccated Edge. What I'd like to show you here is a snapshot that I actually took from one of the episodes of Cosmos 2, the one with Neil deGrasse Tyson, not with Carl Sagan. And it was all about global warming. And what he showed here was a timeline. He was running this as a video. And what's shown here, these sort of color schemes, the black in particular, is where the rate of change of temperature rise is the greatest. Okay? We know that obviously you can have temperature rise in the Arctic, but the sort of rate of temperature rise, and this basically is a proxy for the locality map of the Richtersveld. So this is getting hotter faster. And of course we know that if we run this bit further along, that black spot will expand and basically reach Cape Town. Now some of you may have went to the history of cricket session last week. And right at the end, a thought did occur to me that I think Andre was very sort of passionate about sort of abnormal societies and abnormal cricket and normal and vice versa. And the fact that did dawn on me is that, you know, last summer, the drought actually shut down cricket at the grassroots level. Sorry, pun intended. In the Cape. Now, the schools closed down their cricket program, the clubs closed down. So if you want to shut down cricket, it's all about climate change. And so when you think about it, I think Colin Bundy mentioned 200 years of cricket history. Well, over the next 100 years, basically, cricket as we know it's going to disappear. You're going to have some sort of water-free cricket, or go to Durban and watch the cricket there in a real green field. So the fact of the matter is, all sorts of interesting things, geology, cricket, and other types of activities, tourism and so on, are all interconnected. So it's already hot and dry, but it's going to get hotter and drier if that's possible. Now, of course, there's lots of books out there. This is the one that I think is on sale. This one has recently come out about the introductory aspects about geo-heritage as distinct from other types of heritage. And the heritage parks can include geoparks. It's just that a lot of this book's topics, even though it says Africa, was done by people from North Africa, and it's a lot about the Sahara, which you'll hear tomorrow about from Sharad. These two books have come out recently. Richtersveld was prominent in this one, but also the other side of the orange, so to speak. The desert is also covered, so there's quite a lot of documentation, if you like. There's three slides on words. For example, this probably was in the original application for the southeastern Richtersveld to be proclaimed a heritage site, and it's all about the bugs and the bossies, which I don't know much about, and we're trying to put a geological overlay onto the World Heritage Site. But of course, if you look at this this third line, which was added by my editors. Those of you who know Jasper Knight and Stefan Grab, who are both professors of geography at WITS, it's all about the indigenous people, one of the few places where you get a relatively undisturbed sort of environment, apart from the bossies and the bugs. So what is the sort of geoheritage, the geological overlay, and why is it so important to preserve the Richtersveld as it is now? What can we learn from visiting the Richtersveld? How do we fight for its preservation? And I'm sort of this type of thing. I was almost in a seminar. I could ask you, what did you really find was a highlight of the Richtersveld? And some of these are probably on there, although they're mainly geological. And indeed, I put this to a whole group of international geologists in 2016 when I took a field trip of the International Geological Congress. And they were from all over the world, different ages. I said, why you come here? And basically he said, we want to see the snowball Earth. It's actually, some people think it's a slushball Earth, the less sort of romantic people. And of course you'll see evidence for that, and I'll cover that briefly in the talk, about the so-called cryogenian. So there's evidence for the Neoproterozoic snowball Earth, slushball Earth. I'm probably more of a slushball person rather than a snowball person. Then, of course, we know that the Cambrian, Precambrian boundary, where the expansion of life forms, a great diversity of life, that's also represented in the rock record, in the Richtersveld. And then, of course, if the earlier glaciations weren't important, then we actually have some beautiful examples of the Dwight glaciation preserved in this mountain desert environment. Quite spectacular. So I think there's a whole lot of other things you can see down here. Natural beauty, natural resources, showing ongoing geological processes, and as you know, there's quite a lot to cover. And so I'm going to focus in this talk simply on this glaciation and also this the age of this aretification, the Great Escarpment. How old is this scenery? One of the earlier chapters I wrote, I used the title An Ancient Rocky Wilderness. We'll get onto that a little bit later. So part of this geoheritage is my own, because as a young student from New Zealand, I was sent from one extreme to the other, from New Zealand, Middle Earth if you like, Hobbiton or something like that, something very, very green, to the Richtersveld. And you can see a variety of sort of boy to man, or sort of growing up and surviving and so on pictures. So it certainly was my own personal mentorship and early career development, but it was obviously, certainly, these people's early career development. John de Villiers and Jerry Singer are two pillars of the geological community in South Africa, both Stellenbosch students, but when they were kids in the Second World War years, 1940s, they were sent to the Richtersveld to map it. Probably better than going to D-Day landings or something like that, but certainly they were boys to men. And then, of course, the contribution to knowledge, skills transfer, knowledge legacy, all those are fancy words for taking people to the Richtersveld in order to develop their own early careers. Lots of students. Obviously, you can look at research. Quite a lot of my research, as John said, winning sort of medals and things like that, was based on the Richtersveld. And I sort of make the distinction between stamp collecting and science. And a lot of my colleagues get upset if they just said, you're just a stamp collector. That's historical, what and when, but certainly causal. You know, possibly I'll add some information to that. And then, of course, the Richtersveld has always featured prominently for education awareness, capacity building, student field excursions, conference field excursions, this didactic romantic. Now, of course, you know, as a geologist, most of my photographs don't have any people in it. And quite often, if I stand next to an outcrop looking at the Richtersveld, I'm a didactic. I'm now going to analyze it. Meanwhile, family members and other friends who are not geologists, shut up and just enjoy the view. All right? So maybe I'm in sort of geologist anonymous here. We have to sort of admit that we are on the didactic side of the spectrum, whereas on very few occasions we get dragged towards the romantic side of the genre. certainly in geoheritage, we try to promote that. A lot of this is documented. Of course, these are the books that are on display. Nick and Dave, very good. If you want to know about bugs and bossies, Graham Williamson's book on the Richtersveld is absolutely fantastic. You see that he had a foreword from David Attenborough, and there's 2 editions, so it's been updated. The geology was pretty sketchy, and of course it's dated since. Graham also, of course, generated a small précis, which you can get at the park or even in probably Kirstenbosch bookshop, much thinner, and gives you many of the key words. Also, there's some great maps, and this one here is another sort of small book you can have with you, Tracks and Trails of the Richtersveld, somewhat a mixture of romantic and didactic. That's quite nice. And then a former student of ours, Paul Macy, took him down the Richtersveld and through the Fisher River Canyon as a third-year student, and of course that sparked his own epiphany moment, and he's subsequently worked very hard in producing a geological overlay to the great 85-kilometre walk. The only problem is that if you've ever done it, they walk, they walk, they walk. They don't stop and look and see anything. So this is going to be quite good. He teamed up with Peter Slingsby and have created the geological overlay as one walks. Probably the best one is the Sulphur Springs Trail to Caucus Drift, the 2 outpoints after the main entrance into the canyon at the viewpoint, where you can actually spend almost the same amount of time, 5 days, but only walk about 30 k's and do a lot of geology and a lot of photographs. And it's quite a spectacular walk. My own personal geoheritage of these publications, one was obviously my mentors, and the second was student, and another one myself, which is the guidebook down the Orange River, the portal through the Richtersveld, which is the river itself. This is the frontispiece of, as I said, one of the first things I read when I first arrived in the early 70s. And I remember getting interviewed by John de Villiers, who was a professor and director of the Precambrian Research Unit. And he had taken a lot of people and put them out into the field. And I thought he said, "You may enter the Richtersveld a child, boy or girl, and you will survive, you will return as a geologist." He probably said, "This Land Rover is very expensive and very valuable. So make sure it comes back in one piece, even if you're not." But of course, I'm sure you've all sort of given these words of wisdom. Meanwhile, the people listening are thinking this, cool. I was amazed to see the pictures. His entire photographic collection was archived in the Precambrian Research Unit offices. And these are rolls of 35mm black and white film taken by John de Villiers with a Leica Praktica camera, one of those spectacular top-of-the-range mobile cameras. How they slept, I think the most important one was these Avambo field assistants, field guides, probably the muscle. Especially that guy on the left there, you can see he's got an 18-pound sledgehammer. And this is the granites which John alluded to, where his car broke down on the highway down 5 Mile Port to the border. You certainly needed a 14 or 18-pound sledgehammer to take samples of these granites. Now, I've mentioned the cultural landscape of the Richtersveld, southeastern Richtersveld, the ancient Nama culture. This is a Nama tracker that is standing on a pillar that rises about 300 meters above the canyon of the Orange River. Without that Nama tracker, John de Villiers would never have survived. These pluses of Umbos basically made him survive the Richtersveld, and he was one of those geologists who didn't know better. He said, right, I'll lay a grid over this map and I'll walk this grid. Meanwhile, let's go. That's where the grid line goes. We're going to walk over that, down to the orange and walk back up. I mean, without him, I don't think he would have survived. But the map was spectacular. This is the picture he took. He walked down the Orange River, whereas I paddled. You can see the picture there and below. And so in, 65 years, there's been practically no erosion whatsoever. And I think this is almost like a prelude to the ancient rocky wilderness I'm going to cover. Richtersveld is an ancient rocky wilderness, and it's not necessarily just simply that the rocks are ancient, because any landscape that's developed on rocks is going to be much younger than that. But basically that landscape itself is ancient. It was carved many millions of years ago. And I recall, I think it was in Nick Norman's first talk, he talked about erosional mountains rather than tectonic mountains. Obviously, there was tectonics, and certainly the tectonics in this region sort of date back billions of years. And then they were probably planed down to a flat surface, which is sort of projected above in the sky here. And then, with the denudation of the Gondwana continent, post-breakup and so on, you basically revealed this ancient landscape. And you can see, you can actually sort of subdivide various parts of the landscape into subterranes. And that was the topic of my chapter in the landforms and landscapes of South Africa. Now, on the other hand, let's talk about different types of what they call evolutionary geomorphology. That's what Peter Steffengrab and Jasper regard themselves as evolutionary, and obviously it's an answer to evolutionary biology and so on. African landscapes have length scales and time scales that are very different from what you just saw in the Richtersveld. And so what I've depicted here is the length scale in Africa is long. It's sort of vast sort of vistas, hardly any sort of landscape changes. And the time scale is also long. So that's showing you basically nothing happened for long periods of time. And then little things happened along that timeline. So this is like old to young. This is effectively the view you're seeing. There's another one which actually got a road in it. I'm sure a lot of you have driven these sorts of roads. They sort of seem to go on forever. And again, length scale long, time scale long. But the other extreme is where I actually came from, in New Zealand, where you've got a length scale which is a little bit like this. It's sort of down like this, you know. Whereas a time scale, again, it's very eventful, if you like. So you basically have things going up and down, things going sideways, things blowing up and coming down and doing this. And if you think I'm doing the haka, then actually you're very perceptive. So, for example, this, maybe I'll turn this off to get the... This is a picture of the Alpine Fault in New Zealand, the west coast. And it's pouring of rain. Obviously, you can see the road that crosses it briefly. Ultimately, it's either going to be broken in half by an earthquake, as John was saying, or it's going to have a sort of landslide. Some of you, sharp-eyed, may actually make out the green band, which is the fault gouge along the Alpine Fault. And here's some great stats. The uplift rate along the Southern Alps is 12 kilometers per million years. Okay? The plate convergence, the actual movement of the Pacific plate against the Indo-Australian plate, is of the order of 60 million years, 60 millimeters per year. Okay? So obviously, because of the oblique nature of the collision, you've got something going up and things going sideways. Now, if you've got 12 kilometers per million years, the highest mountain in New Zealand is Mount Aorangi Cook, which is 4 kilometers high. Okay? So I'm sure you can do the simple arithmetic. The erosion rate over a million years is 8 kilometers. Okay? Let's compare the erosion rates in South Africa. Today, 10 to 40 meters per million years. In the past, they thought this was really humming in the past in the Cretaceous. It's still only 150 meters per million years. So there's orders of magnitude differences. So that's the time scale and the length scale. However, the Richtersveld is a sort of exception. It looks like it's got a New Zealand time scale and a New Zealand length scale, but it's actually a New Zealand length scale with an African time scale. So it's a mix like me, it's a bit of a mixture. And so this is obviously a little bit like New Zealand in terms of length scale, but it certainly is an ancient terrain that was only eroded and revealed about 50 million years ago. And it's basically been more or less stagnant since then. The position of the Orange River hasn't changed. And in fact, to cut a long story short, you can see that this great big meandering river has cut down into something that was probably covered with something quite flat. The Karoo was actually on top. You'd actually started to emerge this huge basement landscape at a later stage. So it's all about landscapes. And this sort of dwell on landscapes for a few slides. We can see that the Richtersveld is actually part of the Great Escarpment. It cuts right across the middle of the Richtersveld. And so it's obviously all about escarpment evolution, escarpment degradation and formation and so on. If you look at the DEM, it's probably even more spectacular. You can see here this escarpment region, very high on the eastern side, beveled down towards the lower, but this great big catchment, as Nick was talking about, the great big rivers of Africa. The Orange actually comes through. It's one of the only places where a major river draining the interior of the plateau actually cuts across the escarpment. Here's a closer picture to show you the sort of drainage of the Orange. Goes through there. Some of you may ask, why does it go out to here relative to this way? Why is there a big bend? To cut a long story short, if I get muddled towards the end, Duiker glaciers. Let's think of Duiker glaciers. 300 million year old valleys that are filled with silt that actually cause the Orange River to move along them rather than the hard rocks on either side of the valleys. For example, this is a typical west coast profile where you've got effectively a coastal plain, very, very high vertical exaggeration, so it looks almost like New Zealand, sorry. Then you've got the escarpment, and you can see it's quite strongly dissected, and then you have this high plateau. If we run it along the coast, you actually see some very interesting features where the actual escarpment is not continuous. And these are huge through valleys. The Orange River is the biggest one. The Buffalo River is obviously a subsidiary one. And again, think glacial valleys that cut through the escarpment simply because they were there, and then the rivers followed the ancient sediments. The escarpment may well have been continuous in height, but because of these ancient glacial valleys full of silt, much softer than the hard rocks on either side, the rivers flowed preferentially down there and exhumed that preferentially relative to the Namaqualand highlands. Just a brief description of some of the recent science that we've done in order to establish beyond doubt the antiquity of these ancient mountainous landscapes, like the Richtersveld, like the Cape Fold Belt, and maybe even the Barberton mountain land. We use a variety of radiometric age determinations, and it's all about trying to take minerals out that we can date, and we are dating the time they went through a certain temperature. As you know, deep in the earth it's very hot, but as the rocks come up through exhumation from above, they start to cool. And then they go through what they call closure temperatures, and if we have some idea of the thermal gradient, we can relate those temperatures to depth below the surface. That is to say, if we take a rock on the surface and it has 100 million year old age from these results, we know that it went through X kilometers 100 million years ago. And if that X is, say, 10, then we know it's taken 100 million years to go 10 kilometers of erosion, and so on. So we can do it on surface outcrops, borehole core, and in deep mines. So a lot of this thermo-chronometry has actually sort of basically rewritten the textbooks and all the earlier models of these ancient erosion surfaces being there for millions of years. What I'm getting at is that if you actually take a place where the rocks are coming up quickly, and you basically take, and you have a lot of relief, you can actually take samples from the tops of the mountains down to the bottom of the mountains, because you've got this incredible exposure of the crustal segment. And if you plot the ages that you get against the altitude in the Himalayas, you get a linear relationship. And that's telling you that during this period of time, there's been relatively constant uplift, but also the numbers down here show you when this type of process is occurring. And that's only 6 million years that it's gone from that sort of altitude to there. So that's quick. New Zealand is obviously also quite quick. We can also use other types of radiometric techniques. Again, you can see the details there. You get closure temperatures, and you basically, the important thing is that you get dates when the minerals were at that sort of depth. Okay? So if this apatite gave an age of 10 million years, then it was 1.5 kilometers or so at depth, and 1.5 kilometers of erosion has taken place. So to cut a long story short, in the case of South Africa, if we have constant uplift and erosion over time, then you get a situation like this where you plot elevation against age. On this particular case, you can see there's an inflection. And so what we have here is obviously fast uplift if we get that sort of line, and slower uplift if you get that sort of line. And quite a lot of the thermo-chronometric profiles of the outcrops around the escarpment in the Western Cape are giving these types of profiles. It was uplift quick, way back, but very much slower. A lot of erosion way back, very little today. So a lot of those mountains like the Cape Fold Belt, like the Richtersveld, possibly others in the east as well, were sort of mountains eroded by rivers, high runoff and fast uplift, maybe 100 million years ago down to as recent as 50 million years ago. But since then, 50 million years, nothing has happened. No erosion, no sort of rainfall, of course, erodification, and no major first-order landscape transition. So that escarpment has been sitting there for tens of millions of years, nothing happening to it. Quite an important piece of information. And this sort of summarizes what we call here the time before present and the amount of denudation. There's a lot of lines down here suggesting that very close to the present day, the amount of denudation is quite small, whereas you go back during the Cretaceous, 120, you get sort of numbers up here. So using these sort of data, we would interpret all those mountains of the Richtersveld to have been carved during this period, and then have been left relic. And it comes back to, perhaps some people talk about Martian landscapes. We know a lot about Martian landscapes these days, and I'll show you some pictures. I mean, the similarity is amazing. But both of those share the feature that they're ancient. I think even in the case of Mars, they look like the Karoo, beautiful stratified sediments, but it could be 3 billion years old because nothing's happened in the latter stages of Martian evolution. The geology of the Richtersveld, briefly talk about rocks. There's 3 types of rocks, sort of young, middle-aged, and old. And some of them are soft and some of them are hard. And of course, predictably, the landscape is controlled by the different scales of hardness. The important thing is the western side has got a lot of different hardness rocks, but it's all plain flat. So that tells you something about the erosion history of the West. Whereas in the center, you've got all those mountains, and you've got different colors of rock. And suffice it to say, the hardest ones are these blue guys, some of the softer ones are these other multicolored guys, and that's why you get this higgledy-piggledy sort of mountain ranges. It's shown here, an attempt to show in the Google Earth, where you basically have the mountain belt, the highlands, the west coast, and then the eastern interior. If you want to look at some of the detail of the topography, there's a whole series of cross-sections. The interesting thing about the escarpment in the Richtersveld is that it's not just a simple step like that. Because the Orange River broke through, it started to erode the other side. So you have an escarpment on both sides. And then you have the interior plateau. So it's not a simple escarpment, it's a composite escarpment because of the passage of the Orange. And similarly, if you take a section which is parallel to the mountains, you get variations in the mountains. And these big dips are thought to be these Duiker valleys. So 300 million years ago, this whole landscape was carved by glaciers, generated small valleys, and as the ice advanced, you then generated a huge ice sheet. And then as it actually started to melt, you basically then started to fill the valleys with silt and then build up the Karoo Basin on top of that. But then, of course, you had uplift during the breakup of Gondwana land. The rivers carved down through the Karoo and then exhumed and followed those original glacial valleys. And so that's basically why you get the Big Bend and the meanders in the Orange River. Now, I'm just going to show you how I've sort of changed the landscapes, or classified the landscapes, but I'm not going to talk about all of them in detail. There's not enough time. So I'll just talk about one terrain and its variation, quite a few interesting things. You can see that you can subdivide a west, the central, and then, of course, the east. But then, of course, the central can be divided into a sort of central and east. And then, of course, carving through it is the Big Bend of the Orange River. So each of these individual terrains can be described in detail, but all I'll do is that I'll take you down the Orange River in canoes and look at some of the landscape subterranes within the Orange River Canyon, what sort of interesting rocks are there, and perhaps some explanations. We normally start, the portal to the Richtersveld is a border where the N7 comes up from Cape Town and it crosses the border, and that's way back in 1974 when the river actually was full of water. Actually, before I got here, the water had gone right over the bridge and it washed out everything around Fieldstrift, the hotel, the cop shop, everything. And that road was actually washed away. And of course a lot of the Noduva area as well. But you note that this is looking south, so this is a east-facing escarpment. So that is a retro-escarpment, and the reason for it is that there's a big valley that was a Duiker glacier, so it's lots of shales and things that were originally worn out, and basically the Duiker ice sheets came and banged up against this basement cliff and sort of was deflected to the right, effectively the start of the Big Bend of the Orange. As one goes further, you'll find that the Orange River carves through extremely hard rocks, and that has been inherited from an antecedent drainage. You've got granites which are young, you've got old volcanic rocks which are old, and of course these are spectacular exposures for geologists to see this, the contacts and the relationships as one sort of paddles down the river. Here you've got a situation whereby the orange is fairly homogeneous bedrock in this particular case, so you get all these granites and syenites which are roots of ancient volcanoes. Those people who have canoed down, this is right next to King Kong, which is one of these big hills that got eyeballs and nose and face. It just looks like King Kong campsite. The big meander at Shambok, this is the favorite place where everybody capsizes. You see this big meander here, which is inherited from the days when this river was meandering across the Karoo Plains. It's now gone into quite a mountainous terrain here. You'll note that the river is starved. Huge valley. And there's no interlocking spurs. This was an ancient 300 million year old sort of glacial valley, or a complex of glacial valleys when the Duiker glaciers carved up the pre-Duiker terrain. And it's starved for two reasons. One, because the valley was exhumed by a glacier. And two, the amount of water flowing down is nothing like it was during the ice ages or even earlier. We know that the big dams on the river are also sort of stopping the water, but the important thing is you get these huge sort of rock platforms called straths, which are exposed. This shows you, again, probably more sort of romantically, at sunset, the starved Orange River sort of coming in and forming this massive rapid where everybody capsizes down there, Shambok Rapids. These straths up close, you can see here the channel of the Orange River is obviously very confined into the middle, a small proportion of the Great Valley, but of course the flood times, you generate this sort of rock strath, and in particular you get this sort of cavernous type of erosion, which of course is an insight into diamond entrapment, because they tend to fall in the little spots here where the potholes are. Obviously, during violent water flows, you get transport of diamonds, okay? And then when it's tranquil, you get diamond deposition. So underneath this river flow, you get the potholes, which are the places where the diamonds are found. 7 pillars, you can see the 7 pillars here. 7 pillars of wisdom, if you remember your literature. It was named by an erudite German by the name of Rudi Benneker, who started a diamond mine in that region. This is the top of 7 pillars. And there's a young student. This is in December. The temperature was 47 degrees. So you certainly are going to survive. You're going to be... But you note that this river is huge. The water flow is small, but you can see this ancestral high series of terraces. You can probably make out a little bit of houses and things and bit diggings here. That is the 7 Pillars diamond mine. That's a closer picture. And it shows you that these are ancestral, probably the middle rather than the proto alluvial terraces down the lower Orange. But basically the miners were basically digging out the gravels, trying to find the bedrock, which you can see here, and then putting it through their dense media separation facility. Here's a picture at the mine itself. We're sort of jumping down here, and you can see the workings, and the alluvial diamonds were won from that particular locality. But there's some more wisdom from 7 Pillars. What I'm going to show you is what's going on in this little niche here, in this big quartzite cliff. Go a bit closer, you can almost make out some sort of horizontally bedded rocks. It's covered with landside debris from these quartzites. If you go up there, you'll find these very, very thinly laminated valve-like glacial sediments. If you go further around, you'll see drop stones. And some of the drop stones are bigger. Those people who've been and seen the Duiker in the Mokkiesfontein, Langsberg area, or in other parts, even in KZN, this is part of the Duiker glaciation that is actually perched up on the sides of the Orange River, which gives you the sort of field evidence to indicate that the Orange is actually flowing. It's flowing along the axis of an old 300 million year old glacial valley. And as you continue down the Orange, you will see these perched Duiker glacial valleys. Here you can see the color contrast, these orange shales, these sort of curvilinear sort of patterns. Further along there's several pictures going down towards the Alsenkeer area. And then finally, looking down towards the Alsenkeer plains, you can Alsenkeer plains, you can see where the valley glaciers merge to form a huge piedmont. Right? If you go a bit further, what I'm showing you here is a Landsat image. You can see the Orange River there. We were basically coming down here. This is the Alsenkeer plains where all the table grapes are growing now. And you can probably see this orangey sort of patch of rocks. If I add the sort of interpretation, you can see here that this is a huge patch of Karoo, which is overlapping onto this basement. The rocks are still preserved here. One of the earlier slides I showed you a cross-section of the topography. This glacier probably continued this way. The other one where the notch in the cliff was down here. So certainly the ice flow has varied through the Duiker times from sort of almost westwards or to southwards. So what we're looking at is the remnants of the valley glaciation that has actually had a profound influence on a variety of things apart from the Orange River. Okay, so if we go down to the base of the Duiker, we can actually see the scarring. Here, for example, This is debris from the Dwika, and here is the Nama, another sort of rock type which forms a sequence. Shucks, that's why I don't like being in the dark here. You can see close up that these big scours are caused by ice sheets riding over the bedrock. So that's the base, and on top of it would be all those tillitic rocks. Here's another example. Now this is quite instructive. Here the striations of the Dwika glaciers are on a slope. This is the Orange River. Okay? So this shows you the profile of the original Dwika glacial valley that's actually followed faithfully by the Orange River. Here's another picture from the other side. You can probably see the sort of polished striations of the bedrock and the smearing of the Dwika shales and tillites on that ancient glacial valley. So the Orange River, the modern Orange River, has exhumed an ancient 300 million year old glacial valley. And here's a picture of the overall area. This shows you where the Felix Unity River Camp is. Here's the orange. All this is Karoo. All this is Dwika. The ice sheets you can imagine flowing down here, channelizing into some places, and maps forming a piedmont over the top, which becomes a drape. But as the drape was removed by the ancestral orange, you basically followed it. Now, of course, I could continue going down the Orange River and see other sorts of cool stuff, but obviously now your attention is, hey, glaciers, cool, glaciers. Pun intended. Well, let's have a look at other sort of glaciations that are sort of preserved in the rock record. Here, for example, is what gave rise to the snowball earth box in that book by Nick, Off the Beaten Track. Here you can't see any of the old landscape features because the older sequence of rocks have been quite strongly deformed. But you can probably make out, some of the people in the audience probably recognize their cars here. When we went down with Paul Macy in 2011, we went to the Caicus River, and we see these beautiful sort of glaciated or glacial debris materials. You can see all the fragments and stuff like that here. So that's the so-called Caicus glaciation, much older than the Dwika. And if we actually look at a summary sort of stratigraphy diagram, we got time. Put the light on now. We've got time. This shows you age of the Earth, 2 billion, 1 billion, and then down to the end of the so-called Precambrian. The Caicus glaciation has been dated about 720, and it forms the base of the so-called Cryogenian. Now, in northern Namibia, they found the equivalent of the Sturtian glaciation, 630, which actually forms the end of the Cryogenian. The Numies glaciation, the colour scones, the greens are actually found in the Richtersveld. The other ones are parts of the South African rock record. And perhaps other candidates for global snowballs or global slush balls. Certainly Makanyane, Caicus, and Sturtian, maybe even Numies. Pakes, on the other hand, which you will see on the way up the N7 at the Cedarberg, and the Dwika, which I mentioned, which sort of forms a drape over all these sort of basement rocks. So there's a lot of stuff about glaciation. So if you want to see stuff, hold stuff, there's some there from the Caicus and the Numies. You've seen the Dwika in previous lectures. And so let me finish with another feature. Can the Richtersveld be of any use in terms of understanding planetary landscape evolution? Is it a good analogue for Mars or the Moon? You've probably been to all these sort of desert places around the world. They talk about moon landscapes. And more latterly, they're probably talking about Martian landscapes, because we know more about the Martian landscapes. And indeed, here's a picture. This, as I said, looked a little bit like the Karoo and around Craddock. But these are obviously stratified rocks, desert landscape, arid, stratified rocks. Those are probably key words. Here's another two pictures. Obviously now there's thousands and thousands of pictures from the surveyors. Sort of dusty mountains, lots of stratified rocks. Another one, other stratified rocks in the Martian. These are real Martian photographs. Oops. Then we have a Namibian Karoo Martian landscape, which, as I said, I'm trying to sort of overlay. Yeah, look, you could be. And if you wanted to be the first geologist on Mars, what better place to go to is parts of the Richtersveld. And here's some budding sort of Martian astronauts, better known as geology students, sort of embracing the temperature there was about 45 degrees. So I'm not sure what the temperature is. You have to go and chat to Matt Damon and so on. But certainly the stratified rocks, arid, even some of these pictures are showing you the sort of platy. This is actually the white band, the White Hill, which is quite characteristic of the Langsberg area. But these sort of could well be on Mars. Even this, there are probably people living in apartments in New York and Japan who probably say, well, that looks like something I'd find on Mars if I ever found life, because I've never seen a kokoboom before. And if I want to make it even more persuasive, I could actually make it look like a Mars rover sort of thing, and then you can see the sort of Martians as well as the Mars trees and the Mars rocks and so on and so on. So certainly, I was asked this question when I had to write this paper on landscapes. Is it a lunar landscape or is it a Martian landscape? It's more likely to be an analogue to the Martian landscapes now that we know that a lot of the area where they've surveyed is covered by stratified rocks, possibly laid down by early water, just like these were. This is a sort of Matt Damon landscape of Mars, and this is the Zachary Smith Namibian Karoo Martian landscape, where we tried to depict a sort of local Matt Damon. Some of you may know Zach is Craig Smith's son. He was a postgraduate student of mine at UCT. So certainly one would argue that the Richtersveld is a very good candidate for the Martian landscape. You want to do the Richtersveld? That's the Shambok fluorite mine. You obviously certainly have done the Richtersveld if you've done this at the King Kong campsite. Those people who were with me in 2011, we went down the Holgat River Traverse and looked at all the sandstones. And you've probably seen this meme on Facebook, which reminds me of that very locality. And there's students now, sort of 10 years on, remember this fondly. I did it. I survived. I'm now a geologist. So many questions and so few answers. But I'll get by with a little help from my friends, and maybe it's time for a field trip. Okay, thanks very much. Well, there's channels within channels, right, isn't there? You have a little small channel, which is where the perennial flow goes, but the major channel, which only gets flooded once or twice a century. Sometimes you get a trickle about a centimetre during the floods that we get down the Orange, that far, because it's been kept up by the dams.
So that glacier couldn't open that area because the rock was too hot?
Well, I think it didn't have time. I mean, basically, glaciers form valleys when they're temperate, when it's actually warm. And in this particular case, obviously the Duiker glaciation was at its onset stage. So you had valley glaciers as being the first, and then of course what happens is the ice builds up and the valley glaciers get overwhelmed, and then the base of the ice sheet then becomes frozen. So no erosion takes place. It's only when the glaciation event wanes, it comes back to the possibility of. So I think that's the reason why the valleys were sort of separate.
What is the incidence of wind?
Big time. Big time. And we recall one of the earlier slides, we thought that maybe the Richtersveld could be a place for renewable energy. Certainly wind. And you've noticed the major sand plumes that drive off the Orange River and go north into the Namib. And of course, during the Ice Age, a million years ago, the winds were probably 10 times higher, if you could perceive of even higher winds. I mean, the winds are so hard that even diamonds were moved because of the density.